example, stock price fluctuation. So for this example, for this problem, we are giving a stream of records about a particular stock. Each record contains a timestamp and the corresponding price of the stock at that timestamp. Yeah, so let's just continue to understand what we are doing. So currently we just know that we're gonna have some records and we're gonna have a timestamp stamp, and for each of the timestamp we're gonna have a stock price. So this is currently what we are giving. So unfortunately, due to the volatile nature of the stock market, it means the record do not come in order. Even worse, some records may be incorrect. Another record with the same timestamp may appear later in the stream, correcting the price. So for example, current for time 1, the price is 4, but when it comes to another time, maybe for time 4, yeah, maybe for maybe for another time I want to update the price. Maybe for this time 1, I'm gonna update it to time the price gonna update it to 5 because this is wrong. Or maybe for time 2 the price is 5, and when it comes to another time 2, I'm gonna update it to 10. Yeah, because the previous is wrong. This is what's the meaning of the update function. Yeah. So let's just try to understand. Yeah. So we're gonna design an algorithm that's gonna update the price of the stock at a particular time step, correcting the price. Yeah, so this means it's gonna have two meanings for this update. So for the first, it's gonna have a time. For example, at time 1, we're gonna have a price of $10, or maybe yeah, just after some time we need to correct it. Maybe time 1, the price gonna be $100. So this is exactly what we are doing. Yeah. And then we're going to find the latest price of the stock based on the current records. Yeah, so for example, for the records, we have 100, 200, and basically this is the curve. And we're going to find the latest stock price. It's going to be the latest time, which is going to be here. Yeah, so this is the latest time. And we also need to find the maximum price of the stock and the minimum price of the stock. Yeah, so according to the stock, basically we need to find the maximum price. It's going to be here, and the minimum price maybe it is here. Yeah. Now let's just check what we can do to solve this problem. So currently we are giving this class stock price, and the current we're gonna return the latest price of the stock, and maximum gonna return the maximum, and the minimum gonna return the minimum price of the stock. And for this update, we're going to update the price of stock at the given timestamp. So for this problem, because we are going to calculate the maximum and minimum stock price, so what kind of algorithm we can use? So in Python, we can use a sorted list, because inside of the sorted list, basically we can calculate this maximum and minimum price easily. And also we need to know at a timestamp, for example 1, what is the price. Yeah, we need to have a dictionary to store the stock price at a different timestamp. So this means we're gonna need a dictionary, and then we're gonna need a sorted list. Yeah, so the sorted list gonna store all the stock prices, because basically we want to find the minimum, maximum, and the current. And we also need to define another variable. Let's say it's gonna be the latest, because we need to find the latest time, and then we're going to use the dictionary to find the stock price. So this is exactly what we are doing. We need a variable latest time, so this is going to be the latest time, and we need a dictionary. Yeah, it's going to be store the time step to the stock price k-value pairs, and we also need a sorted list, which is going to store an array of prices, because we need to find a maximum and a minimum price. So this is exactly what we are doing. Yeah. Now let's just try to solve it. So we're going to define a dictionary. It's going to be a default dict with integer, and we're going to define a sorted list. So it's going to be the sorted list. Yeah. And we also need to define a variable. Let's just call it latest, because we need to have the latest time. In Python, we cannot directly use the sorted list. We have to import it. So at least for Leetcode. So we need to import it. So from unsorted containers, so we're gonna import unsorted unlist. Yeah. Now we're gonna just try to solve the update current, maximum, and minimum. Yeah. So what's gonna be the current? So for the current, basically we need to find it inside of the dictionary. So self.d, and we need to know the time step. So what is the latest time step? It's going to be the self.unlatest. Yeah. So this is going to be the time step. So basically, we need to return, this kind of a dictionary. So for the maximum, we need to return self.sorted list with -1. This is going to be the maximum. And for the minimum, we need to return self.sorted list with 0, because according to sorted list, it's going to be sorted, and this is going to be the minimum. So the difficult part is how can we solve this update? Yeah, because for the update, it's going to update the price of stock at a particular time step, correcting the price from any previous records in the time step. Basically, there are two functions. For one function, we can update the price at any time. For another function, we can correcting the price from the previous records. So basically, there are two operations. So yeah, for the first operation, for example, at the time step 1, we're gonna have a record. Another function is at the time 1, we're gonna update it to another value, maybe 100. Yeah, so this is basically the update function. So what about the sorted list? Yeah, so for the sorted list, basically we need to add the price. And what about the latest? Basically we need to choose the maximum value for the self.latest and with the time step. Yeah. And what about the dictionary? And basically, because here we're gonna need this kind of a dictionary, we need to have a record. So self.d with time step, it's gonna equal to the price. Yeah, but this is not finished. So currently, we're gonna use this dictionary to have a record, to have a time step, and then we're gonna have a price. Yeah. So for example, let's just use an example. For example, at time 1, we're gonna have a stock price of $10. Yeah. Now we're gonna add this $10 to the sorted list. So this $10 is gonna be inside this sorted list. Yeah, and we're gonna also have the latest time. It's gonna be 1. So this is the sorted list. So after some time, we're gonna use another update. So for example, this time step 1 gonna be updated to 100. So what's gonna happen for this 100? Yeah. So currently for this dictionary, this self.d time step gonna equal to 100. So this is okay. Yeah. So for this time step at 1, it's gonna be $100. Yeah. And what about this sorted list? So for the sorted list, it's gonna add another value. It's gonna be 100. But of course, it will be wrong because this 10 is not exist, because this $10 has been updated. Yeah, because this $10 for time step 1. This means we need to remove this $10, but how can we remove it? And for the latest, it is okay. It is still 1, so it is okay. Yeah. So here we have a problem. This means for this $10, we need to find this $10. Yeah. So this means before we update the time step to price, basically we need to find the old price. So let's just define it as old. So it's going to be self.d with time step. And we need to remove the old price. So let's just set the old price. So we need to remove the old price from the sorted list. Yeah. So we're gonna remove the old price. Yeah. But for those two lines, basically we need to check if it is inside, if the time step is inside the dictionary. Otherwise, we don't need to do that. Yeah. But let me just run it. As we can see, it didn't work. Yeah, because here 0 is not inside. Yeah, because we didn't find it. This means we need to have another check. So if time step inside the self.d inside the dictionary, So we're gonna find the old price and we're gonna remove the old price and then we're gonna add it to our sorted list. So this is gonna be the new price. Yeah. Now let me just run it. Yeah, it's gonna be the latest. Did I do something wrong? Let me just copy this latest. I think I made a mistake. Something wrong with the typo of the latest. Now as you can see, it works. Now let me just submit it to check if it can pass. Now as you can see, it passed for all testing cases and it's pretty fast. Yeah, so for this problem, let's just analyze the time complexity. So for here, there are going to be 10 to the power 5 calls of this updated current, maximum and minimum. Yeah, so let's just check each one of them. Yeah. So for this self.sl0, this is going to be O1 time, -1 O1 time, and dictionary, this is going to be O1 time, and for here, this is going to be log n time. So this means the time complexity is going to be n log n 10 to the power 5 times log 10 to the power 5. This is why, yeah, it works. I think that's all about it. Thank you for watching. See you next time.